We're on page 38, topic 8, and the problems that we're going to do are 4, 13, 14, and 20. So starting with problem 4, we're supposed to graph this linear inequality. And you'll notice that we have a fraction on this side here, on the right side, and we want to get rid of that 3. So in order to get rid of that 3, we're going to multiply each term in this inequality by 3. So 3 times y gives us 3y. 3 times minus 4/3 x gives us minus 4x. And 3 times plus 4 gives us plus 12. This clears the fraction now. Now, when we want to get the boundary line for this inequality, we're going to just, instead of using this greater than, we're just going to put an equal sign here. And we just do it for the purposes of finding the boundary and line. And in order to do that, we need to find the intercepts. Or the easiest way is to do it is to find the intercepts. So what we're going to do is take this equation right here, and what we do is we set x equal to 0 right here. So minus 4 times 0 is 0, 3y equals 12, and y equals 4. So when x is 0, y is 4. Now what we're going to do is take this same equation and set y to 0. So if this is 0, 3y is 0, and 0 equals minus 4x plus 12. We bring this over to this side and we get 4x equals 12 and x equals 3. So when y is 0, x is 3. So we now have two ordered pairs. One of the ordered pairs is 0, 4, which is one of the intercepts. And the other ordered pair is the other intercept, which is 3, 0. So now we set up the graph. Here's the y-intercept right here, 0, 4. Remember, we set x equal to 0 to find the y-intercept. So we have one intercept, and then we have the other intercept, which is 3, 0, which is this over here. Now, since we have 2 points, we connect these 2 points, and we connect them with a straight line. In this case, the boundary line will be dotted because the original inequality right here does not contain an equal sign. There's no equal sign. So it doesn't actually include the line itself. So now we have to decide which side of the line we're going to actually shade on. And we're going to start off with a very obvious point, which is 0, 0. That's clearly on one side of the line right here where the origin is, 0, 0. And we're going to see if the point 0, 0, if we substitute it into the inequality, whether the inequality is true. So we're going to test with a point 0, 0 and substitute into this. So we're going to replace the y with a 0 and the x with a 0 and ask, is the inequality true? So is 3 times y equal to 0, greater than minus 4x, x is 0, plus 12. 3 times 0 is 0 on the left of the inequality. This term is 0, so we're left with 12 on the right side. Is 0 greater than 12? No, 0 is less than 12. It's not greater than 12. So the inequality is using 0, 0 doesn't work. So we have to shade on the side of the line that does not have 0, 0 in it. In other words, we're not going to shade on this side of the line right here. We're going to shade on the other side of the line right here on this side of the line. We're going to shade. And that's why we have these lines drawn here. And that is now the graph of the inequality that we were asked to draw. Now, what we can do is we can check the answer by choosing a point on the shaded side. I mean, let's choose a very obvious one here. If we move up here, we know that, for example, 3, 1 is clearly on the shaded portion. So let's just check if the point 3, 1, and this is arbitrary. We could have chosen, for example, 4, 0 or 5, 0. I chose 3, 1 right here. It's arbitrary what we choose as long as we know clearly where it is. So we're going to substitute 3, 1 into the expression and see if it still holds true. So we're going to ask now here 3y, and y is 1, so we're going to say 3 times 1 greater than minus 4x, which is right here. We're going to place the x with a 3 because this is a 3 plus 12. So 3 times 1 is 3. Minus 4 times plus 3 is minus 12. Plus 12 is 0. So we have minus 12 plus 12. That gives us a 0. Is 3 greater than 0? Yes, it is. So the point 3, 1 is correctly on the shaded side. So the graph must be shaded on that side of the line that contains 3, 1. The next problem is number 13. And here again we are asked to graph the linear inequality minus 3x plus hy plus 12 greater than 0. The first thing we're going to do is find the boundary line. So we're going to set this equation equal to 0. In other words, we're going to remove this term here and just put an equal sign in. And if we let x equal to 0, minus 3 times 0, 0, we get 8y plus 12 equals 0. We transpose the plus 12 from the left to the right, and we get 8y equals minus 12. Now we divide this side by 8 and that side by 8. When we divide 8y by 8, we get y. And when we divide minus 12 by 8, we get minus 12 over 8. Now we reduce this, and you can realize that 4 goes into both these numbers. 4 goes into 12 minus 3, and 4 goes into 8, 2. Now you could also reduce it more simply by, first of all, dividing 2 into both the numerator and the denominator, and you get minus 6 over 4, and then reduce it again, and then divide 2 again into 6 and 4, and you'll get minus 3 over 2. Minus 3 over 2 is minus 1.5. So now we've set x equal to 0 and y equals minus 3/2. So that's one ordered pair, 0 and minus 3/2. When we set y equal to 0 in this expression right here, we get minus 3x plus 12 equals 0 because this term doesn't count. 8 times 0 is 0. We get minus 3x plus 12 equals 0. So we know that 3x equals 12 and x equals 4. So now we have the ordered pair x is 4, y is 0. So here's x is 4, y is 0. Here is x is 0, and y is minus 3/2 or 1.5. We connect the line, the 2 points, and it's going to be dotted because there's no equal sign. So we check the equation with the point 0, 0, and we can clearly see that 0, 0 lies on one side of the line. It's very, very clear. So we're going to substitute it into minus 3x plus 8y plus 12 greater than 0. We're going to replace the x with the 0 and the y with the 0 and ask, and then we're left with 12 on the left. Is 12 greater than 0? And the answer is yes. So now we shade the side of the line with 0, 0 in it, and it looks like this right here. So here's 0, 0 right here, and we shade on this side of the line from here, all of this, not on this side of the line. Now, just to check, we're going to choose a point that clearly lies on the other side of the boundary line. So here, 0, comma, -2, x is 0, -2, just below this point right here is 0, comma, -2, x is 0 along this line, and y is -2. So we know that lies on the other side of the boundary line, and just check that it doesn't work. So -3x, and x is 0, plus 8y, y is -2, plus 12. Is that greater than 0? So here we get 0, here we get -16 plus 12, so we have -4. Is -4 greater than 0? No, -4 is less than 0. So using the point 0, -2 doesn't work, which is what we would expect. It did work with 0, 0 on this side of the line, so if we choose something on the other side of the line, which we did, 0, -2, it should not work. Okay, number 14 on page 38. Here we have -3x plus 4y less than or equal to 0. We have to graph this. So the first thing is we have to find the boundary line. So we set this equation, we just put an equal sign, and you'll see if I put x equal to 0, then 4y equals 0 and y equals 0. So when x is 0, y is 0. So we'll just set another value, choose a value for x. We're going to choose x equals 4 and find out what the corresponding y value is. So we'll put that into this, -3 times 4 plus 4y equals 0. So we get -12 plus 4y equals 0. So 4y equals 12, y equals 3. So when x is 4, y is 3. Now, when we use x equal to 0, and we find y is 0, if we did y equal to 0, x would equal 0. So we have to choose a second point arbitrarily, and we chose x equal to 4. I knew that that would give me a nice whole number, and that's why I chose it. But you could choose any number. You could choose x equals 1, 2, or you could choose a negative number. Here you can see when x is 4, y equals 3. So that gives me this point here. So one point is 0, 0. The other point is 4, 3. We connect those two, and that gives us the boundary line. And since there's an equal sign here, the line will be solid. So now we're going to choose as a test point -2, 0, which is right about here. -2, x is -2 and y is 0. It's on the x-axis, so let's say it's roughly here. We're going to choose it as a test point. And we're going to put it back into this original equation and ask is, so we're going to put -3, because we have -3. For x, we're going to choose -2 right here, plus 4 times y, 0, less than or equal to 0. And what we get here is -3 times -2 is +6, plus 0. +6 plus 0 is still 6. So we're asking, is 6 less than or equal to 0? And the answer is no. 6 is greater than 0. It's not less than 0. So we must shade on the side of on the other side of the boundary line, not on this side, but on this side of the boundary line right here. And that's what we did right here. We shaded here. okay, on this side, because the minus 2, 0 didn't work. It didn't work with that number. So let's check with a point which falls within the boundary region, for example, 3, 0. Well, 3, 0, x is 3, y is 0, is somewhere around here. So it should work. So let's put it back into the original equation. We ask, is minus 3x when x is 3 plus 4y, where y is 0, because y is 0, less than or equal to 0. So we get minus 9 here, plus 0, gives us minus 9. Is minus 9 less than or equal to 0? It's less than 0, so the answer is yes. So we shade on the side that contains the 3, 0, which is this side here. Finally, number 20, we're asked to graph the linear inequality 4y minus 2 bracket x plus 1 greater than or equal to 3y minus 1 plus 3. So the first thing we have to do is simplify this. We have so many terms, several terms in y, and then several places where we have numbers. Let's simplify it so we have a y term, an x term, and a number. So first thing we do is remove the bracket here, and we get minus 2x minus 2. We use the distributive rule. 4y minus 2x minus 2. Minus 2 times x gives us minus 2x, and minus 2 times plus 1 gives us minus 2. Remove the bracket here. We get 3 times y and 3 times minus 1. Get 3y minus 3 plus 3. So all I've done here is remove this from the left side, from the right side to the left, and made it minus 3y. So the plus 3y here becomes minus 3y here. And I moved the minus 2 from the left side to the right side and made it plus 2. So you can see 4y minus 3y gives me y. I still have the minus 2x, so that's that term. And minus 3 plus 3 gives me 0, and I'm left with 2 on there. So this equation right here is the same as this equation right here. We just simplified it. Because here we've got y on the right and y on the left. We've got numbers on the left and numbers on the right. We've reduced this so we have one term containing y, one term containing x, and we have a number term. Now, to find the boundary line, we set y minus 2x equal to 2. So all I've done is replace this with an equal sign. We're going to set the x-intercept to 0. So to find the y-intercept, we're going to set x equal to 0. So here, minus 2 times 0 is 0, and y equals 2. So when we set x equal to 0, y is 2. Now we're going to find the x-intercept, and along the x-intercept, y is 0. So if y is 0, we get minus 2x equals 2, and x equals minus 1. So we now have the point 0, 2 right here. X is 0, y is 2. And then we have the point minus 1, 0, which is this. So we have the two ordered pairs. We connect those 2 points. And since it includes the equal sign in the original expression, and this one too, but in the original expression, the line will be solid. So now we know that the point 0, 0 lies clearly on one side of the line. So we're going to check the equation using 0, 0. And when we do that, we're going to put 0 here, and we're going to put 0 here. And is 0 minus 2 times 0 greater than or equal to 2? is 0 greater than or equal to 2 because everything on the left becomes 0. Is 0 greater than or equal to 2? No, 0 is less than 2. So we have to shade on that side of the line that doesn't include the 0, 0. So here's the 0, 0. We're going to shade on the other side of the line. These are the two intercepts. And check with a point in the shaded region just to make sure. Here, over here, roughly speaking, would be minus 2, 0. So we check with minus 2, 0. And we plug this into y minus 2x greater than or equal to 2. Y is 0. So I replace this. Minus 2x. X is minus 2. And I come out with the left side, minus 2 times minus 2 is plus 4. Is 4 greater than or equal to 2? Yes, so we shade on the side that contains the minus 2, 0. And that's what is shaded, that side of the line that contains the minus 2, 0.